August 12th, 1944, the English Channel, somewhere between the Isle of Wight and the coast of France. The cable-laying ship Latimer is towing something unlike anything ever deployed before. A 3-inch steel pipe unspooling from a massive drum, sinking to the bottom of the channel as the ship moves forward. In 10 hours, the crew lays the entire line, the longest underwater fuel pipeline ever attempted. Then, before it can pump a single gallon of fuel, an escorting destroyer swings too close, catches the new pipeline with its own anchor, and destroys it. One of the most secret engineering projects of the Second World War has just failed on its first attempt. In full view of the ships assigned to protect it, only a small circle of people understood what the project actually was. Somewhere above that stretch of water, German U-boats are still patrolling. German intelligence has heard a code name for whatever the British are building, PLUTO, and never appreciated what it meant, dismissing it as insignificant. They were wrong about that. And under their own patrol routes, across a beach they had spent 4 years defending, the British were trying to solve a problem that could decide whether the liberation of France ran out of fuel before it ran out of road. To understand why a pipeline mattered this much, you have to understand what an army needs to move. A single armored division burns fuel by the tanker load every day without stopping for as long as it stays in the fight. In the spring of 1942, British planners, looking ahead to an eventual invasion of Europe, understood that whoever led that invasion would face the same problem the German army would later face in reverse. An advancing force can outrun its own fuel supply and stop dead, not because it lost a battle, but because the tankers could not keep up, and tankers were slow, weather-dependent, and an easy target for both U-boats and the Luftwaffe if they were bunched up on invasion beaches. Admiral Louis Mountbatten, head of Britain's combined operations, raised the idea of solving this a different way, not with more ships, but with a pipe under the sea itself. The man who turned that idea into an actual engineering plan was Arthur Hartley, chief engineer of the Anglo-Iranian Oil Company, who had already built a pressurized pipeline across the hills of Iran, capable of moving the fuel equivalent of 20,000 jerrycans a day. In April 1942, Hartley proposed something bolder, a continuous pipe built like an undersea telegraph cable, with a fuel line running down its core instead of a copper wire, deployable from a ship the same way Britain had been laying communications cables under the ocean for decades. What Hartley's team built out of that idea became 2 different kinds of pipe. The first, called HAIS, used a flexible lead core built with the telegraph cable manufacturer Siemens Brothers and the National Physical Laboratory. It worked, but lead was expensive, and Britain did not have enough of it to build a whole channel's worth of line, so a second design followed, called HAMEL, a cheaper pipe made from ordinary mild steel that could survive the crossing without the lead core. Both designs had to be wound onto drums for transport, and the drums themselves became one of the strangest machines of the war. They were called conundrums, steel cylinders roughly 30 feet across, more than 5 times the height of a man, each one carrying 30 miles of pipe and weighing around 250 tons. Tugboats towed them out into the channel, and as the ship moved forward, the drums spun, and mile after mile of pipe sank quietly to the channel floor behind it. Invisible from the air and from a U-boat periscope, the secrecy did not stop at the water's edge. On the English side, the pumping stations that pushed fuel through these pipes had to be hidden in plain sight because the coastline was within range of German coastal guns and German reconnaissance. So the Royal Engineers disguised them. A pumping station might look like an ordinary bungalow, another was built into a barn, and others were hidden inside gravel pits, garages, and in at least one case, an ice cream shop on the English coast, fully operational as a business on the outside, while machinery pumped aviation fuel toward France underneath it. This was the actual camouflage strategy for critical war infrastructure, and it worked well enough that decades later, one of the former pumping stations on the Isle of Wight was still standing, repurposed, this time as a mini golf course. The first attempt at connecting a working line to France, The route, codenamed Bambi, ran 70 miles from the Isle of Wight to Cherbourg, and it struggled from the start. The Latimer's line failed within hours of being laid. A working HAIS cable was not commissioned until September 18th, more than 3 months behind schedule, and when engineers tried to increase the pressure to push more fuel through in early October, both the HAIS and HAMEL lines failed again. Bambi was abandoned. Britain's official war history says plainly that PLUTO contributed nothing to Allied fuel supplies at the moment it would have mattered most, during the breakout from Normandy, when Patton's tanks were burning through fuel faster than anyone had planned for. That is not the version of this story people usually tell. The tanks that broke out of Normandy ran on fuel brought in by tanker, by jerrycan, and by aircraft, while the pipeline that was supposed to make all of that unnecessary sat, broken, on the floor of the English Channel. Engineers regrouped anyway. A second route, codenamed Dumbo, connected Dungeness to the French coast near Boulogne, a shorter 30-mile crossing. And this time, the lessons from BAMBI's failure held. By late October 1944, 17 separate lines, 11 HAIS, and 6 HAMEL, were running under the Strait of Dover, commanded by a special Royal Navy flotilla of roughly 100 officers and 1,000 sailors and technicians based out of Southampton under Captain J. F. Hutchings. Once those lines stabilized, the throughput climbed faster than anything else in the fuel supply chain. In January 1945, PLUTO was moving around 300 tons of fuel a day. By March, that was over 3,000 tons a day, a tenfold jump in 2 months. By May 1945, the network was delivering close to 4,500 tons daily, roughly 1 million gallons, straight from the English coast to the advancing Allied armies, with no tanker required and nothing for a U-boat or the Luftwaffe to find. By the time Germany surrendered, these pipelines had delivered over 172 million gallons of fuel to Allied forces in Europe. Eisenhower, describing the project after the war, called it second in daring only to the artificial Mulberry Harbours, the floating ports the Allies built to unload an invasion where no port existed. PLUTO did not win the breakout from Normandy, and Britain's own official record says so. That failure matters as much as the later success, because it shows what the project actually proved. A handful of engineers took the idea of an undersea telegraph cable, a technology built to carry words, and rebuilt it to carry fuel across one of the most heavily patrolled stretches of water on Earth. It did not work when the invasion needed it most. It worked later, at a scale nobody outside the project had expected, and the operational pipelines were never found or attacked by the German forces guarding that coastline. The reel laying method Hartley's team developed to solve a wartime fuel crisis went on to influence how the offshore oil and gas industry lays pipe on the seafloor today. In the North Sea and the Gulf of Mexico, wherever a pipeline has to cross water no ship can safely anchor in. There was no dramatic moment where a German officer stood on a French beach and realized the fuel was already there, because for months it was not. And the men who built the pipeline knew that before anyone else did. What survives instead is the honesty of officials like Sir Donald Banks, who wrote afterward about how much the team still had to learn about repairing leaks and connecting shore ends before any of it worked reliably. Admitting the failure before claiming the success is rarer in war history than the myths that usually replace it. The pipeline under the Channel did not save Normandy. It proved something else, that fuel for an army did not have to travel by ship at all, and by the spring of 1945, it was proving that at a rate of 1 million gallons a day, underneath U-boats that never found it. If a hidden pipeline, under a battlefield, everyone thought they understood, is the kind of story you want more of, a like helps keep it visible. Subscribe if you want the next one. History has plenty of things that failed in public and worked in private, and most of them never get told at all.